In this week's episode of the Embedded Insiders, Brandon and Rich ponder the question, why do we have solar? Is this energy-efficient innovation really worth it? Next is the fourth episode with ADLINK Technology, where Zane Tsai, ADLINK's product platform center director, about the trend of 5G and the role it plays in AI at the edge. Later, Tiera Oliver explains how Xilinx is simplifying complicated FPGAs with greater hardware architectures, such as their Versal AI engine, and greater software accessibility. According to Victor Peng, CEO of Xilinx, by overlaying domain-specific architectures such as Versal, users can see drastic improvements within their AI applications.
Hello, and welcome to another edition of the Embedded Insiders. I'm Brandon Lewis, here with my fearless leader and executive vice. Oh man, I already screwed it up. I was focused so hard on bringing the juice this time, Rich, that I messed up the intro that I've done hundreds of times. Should I try again, or should we just take it from the top?
No, we're good. We're good.
Well, this is Rich and Ass. I'm Brandon Lewis. We're both from Embedded Computing Design, and this is the Embedded Insiders podcast. Welcome.
Thank you. How are you doing?
I'm doing pretty well. I think I mentioned on the last podcast or two that I've had solar installed at my new house. Which
solar what?
Solar panels to power the house, which are not active yet because the city is in a huge, long delay of permitting. I don't know if it appears that they're blaming it on COVID, but I think that's just sort of the way that the city is anyway. But we don't want to talk about city permitting.
But hang on a sec. Are you such that you use the electricity, or you send it back to the power company, who then does what they want with it?
So you use the electricity, and then right there, real time, and then you can send back any overage. And the way that it works, in layman's terms, it can get really tricky really fast. Is basically I buy energy. Before the plan that I'm on now, I was buying it at about 13 cents kilowatt hour. Now I'm buying it about 4 cents kilowatt hour. But when I sell it back to them, I only sell it back to them at like a penny or a penny and a half, right? So it's like if I buy an apple from you, I give you a nickel, and then you buy it back from me and you give me $1.
Why don't you sell it to your next door neighbor?
Well, because he doesn't have a supercapacitor or a battery or any way to store it. That's actually one of the interesting things about this entire process is if I could, I would love to go completely off grid. If there's a power outage, I don't have to worry about anything. The next time there's COVID, all of my friends are going to want to come to my house because.
Does that mean you're going to hunt for your food and stuff?
Yes, of course. Hunt for my food. We'll start growing in the fertile plains of Arizona. We'll start farming all sorts of.
How much cactus can you eat?
Staple crops. Yes, but yeah, it would be really interesting to be able to get a super cap or some sort of energy storage system. But firstly, they're really, really expensive right now.
Talk to your friend Elon. He'll get you one.
That's right. That's true. I should give him maybe he's only selling them to people with Dogecoin. Is Dogecoin? Anyway, but sort of on this topic, we had a pretty interesting press release come across the desk a couple of days ago, and it was from Littelfuse. And Littelfuse has developed some photovoltaic fuses that integrate directly into roof shingles. So the solar panels that I have are the ones that you mount on top of the roof, on top of the shingles, and they stick out off the roof, and they're kind of an eyesore. And these purportedly enable you to put the entire energy harvesting system just directly embedded into the shingles themselves. And when I saw this, I immediately had a little bit of buyer's remorse. I was like, if I waited 6 months, would I have been able to have the next best thing?
Well, you certainly don't want version 1.0 of anything, especially something that's attached to your roof. But so you would have no asphalt on the shingle. You'd have a solar panel that's integrated into the shingle. Is that what you're saying?
Correct.
Interesting. Very interesting.
Like you said, you never really want to be the first to adopt anything. I mean, with something that's low leverage, like a Fitbit or a smartphone, It doesn't work. It's got crappy performance. Okay, well, that's a nuisance, but you get the super cool fuses, photovoltaic fuses on your roof, and all of a sudden 2 weeks later your house is on fire, right? That's sort of a problem.
Or it
And
leaks and you need a replacement.
yeah, exactly. And gosh, I don't even know where to begin with the homeowner's insurance on that and whether they cover that or not. But it also, on the other side of the coin, if you're the manufacturer of this technology, somebody's got to be first to do it, right?
Mm-hmm.
Do you, how many eggs do you put in a basket like that? I guess if you're Littelfuse and that's really your core competency, you live in that market, you live in that space, you got to be early with that sort of technology. But there's also inherent risk there. I mean, there's a ton of government backing right now around subsidizing the use of solar. So people are putting up solar panels left and right here. That's a whole nother discussion why they already weren't up here in Arizona anyway. But you're gonna make some significant investments as a technology company into something that may take 5 years, may take 10 years, or may never actually get to the market because there's already an incumbent, theoretically lower cost solution out there.
Yeah, I'm not sold on that yet, the whole solar thing. I mean, it has so much promise and they just haven't figured it out. It seems like a no-brainer. And
Well, I said I wasn't going to go down this path, but here we go. We've talked about this before. There's so many times when the best technology does not win, right? There's so many different elements behind what succeeds and what doesn't. Was Windows the best operating system out there in the late 80s and early 90s? A lot of people would suggest not. But in Arizona, what has happened is, at least in Phoenix in particular, is the power companies are essentially monopolies. We have two power companies in Greater Phoenix, and they supply power to two different geographic regions, and you don't have an option. If you live there, that's what you get. You either use the Salt River Project or Arizona Public Service. That's it. You only get the one option. Now, both of those companies sit on what's called the Corporation Commission, and the Corporation Commission is a panel essentially that has 5 seats, and they've got 2 or 3 seats on this commission, and they vote up and down specific legislation that is business related. And for the last 20 years, they have been killing solar. In Arizona, the state that has the most days of sunshine per year in the United States. And obviously, from their perspective, the reasons are obvious. They've already got the infrastructure. They're supplying nuclear and coal power, and in some cases hydropower already. Why do they want to open the door for me to come in here, put a super cap, in my garage or next to my garage, and start eating away at their profits? They're still charging me $32 a month just for the privilege of hooking up to the grid, right? So there's so many different reasons that solar, at least in Arizona, hasn't advanced to the point that it probably should have.
Well, you don't think you're going to generate enough energy from your roof for your whole house, do you?
I am not. And here's another funny thing. So the way that I approached putting this solar on my roof was I'm all for clean energy, I'm all for that whole side of it. But let's be honest, at the end of the day, most of us just want to cut our expenses.
Mm-hmm.
And the benefit of putting the solar on the way that I did was I added enough panels to qualify me for this plan that, again, the power company has created, which says that instead of paying 13 cents a kilowatt hour, you now pay 4 cents a kilowatt hour. So, I am going to be generating electricity and being able to use that for free. But the real cost savings are going to come because now I qualify for this other rate plan, which is a third of the cost of energy before. Now, there are also these huge caveats, like instead of being on a normal on-peak, off-peak system or rate plan, there's still the on-peak, off-peak, except it hammers you when you use energy on the on-peak times. So
The off-peak times being from 7 in the morning to 10 at night?
Well, no. So now it's from 3 p.m. to 8 p.m. And this is where they really get you. And so if you're not incredibly careful, and a lot of people
just keeps getting better and better.
well, if you're not incredibly careful, you can really hose yourself. And actually, people are starting to put load balancers, essentially like demand controllers, where it prioritizes your appliance to avoid this exact scenario. But so the way that this plan works is that during those that time period of 3 p.m. to 8 p.m.
Don't think you're shutting down at 3 o'clock every day.
Right. So from 3 p.m. to 8 p.m., they measure randomly throughout the month your energy usage, and they'll take the highest usage that they gather that month. So, maybe you were using 5 kilowatt hours, at the time that they pulled, for April or whatever. Well, the way that this plan works is that between 0 and 3 kilowatt hours being used, if that's what they measure you at, you pay, I don't know, like $3 per kilowatt hour. So if you use 3, it's 3 for every kilowatt hour. So $9. But if it's between 3 and 7 kilowatt hours used, you pay $6 per kilowatt hour. So 7 times 6 is 42. If you use like 10 plus kilowatt hours when they pull the measurement, which is granted, that's a ton of energy. I mean, that's like, doing every appliance in your house at the same time, all the time. But if you do,
an air conditioner sucks a lot of power.
Correct. So that's essentially between the hours of 3 and 8 in Arizona, obviously, during the summer, your AC is running all the time. So that's all you're doing from 3 to 8. Don't run the dishwasher, don't dry your clothes, don't do anything else. But after, so if you,
but I don't want to hear, I can't work because I've used too much power.
It's true. But anyway, so yeah, like at 10 kilowatt hours and above, they're charging you like $22 per kilowatt hour. So if you're not very careful, all of a sudden you're, walking over to the mailbox or open up your email and you're like, wow, I'm saving so much money on energy this month. This is great. And it's like demand charge $275. That's a ton of money in just essentially service fees. They've invented ways of making money.
So why do you have this solar panel?
You know what? I'll tell you in another month or two once the thing's on.
Now Rich and Zane Tsai of ADLINK Technology discuss how edge computing, AI, and machine learning are implemented in various applications, and how highly efficient computing power affects the success of these technologies.
Where does imaging fit in? Because the applications we're talking about all have some aspect of imaging built in.
We need a powerful computing engine to handle all this imaging taken from the real world before it can be analyzed and generate some logic to execute. So first of all, we have to do some frame grabbing and to digitize those analog signals from the real world. And then we have to stream them into the compute engine, which also needs to process all this data before it can generate any insights for execution. And so that involves several parts, and that also brings up some challenges that require this computing engine imaging technology. Let's take some real world example. A very typical HAI or edge computing application will be medical imaging, like ultrasound or endoscope. That requires some instant response to the imagery captures and to reveal all the necessary information to the doctor for diagnostic. So let's just take this for example. So when the sensor, the probe, putting on this to the symptom position of the patient, it has to grab this image and digitize this and stream it to the machine, this diagnostic machine. And in this process, as the growth of the resolution requirements in this medical image, there's a growing difficulty to transfer this kind of amount of data. So that requires some spatial technology and to resolve it. And luckily, ADLINK has co-working with our partners and move some technologies that is never been used here and applied it. We call it, it's a remote DMA for the memory and storage. With this technology, it can actually boost this data moving and transition like 80% more than the traditional way. And that actually helps a lot in the data, large amount data transmission. And second, you have to have a very powerful codec that convert this compressed image or this accumulated image into a raw data before you can be analyzed. And that's also requires some operation inside the processors. And last but not least, you also need a powerful inference engine inside the processor, and it helps you fully utilize the distinct features in different type of the accelerator in CPUs, GPUs, FPGA, and VPUs. After all, who can help to fully utilize and squeeze all the performance from the chip is the chip vendor. So they will provide you a different inference engine that can fully utilize their computing power inside these processors.
One of the things we haven't talked about here is where third parties and ecosystem partners fit in. Can you talk about that a little bit?
To put all this together, we need actually a different type of sensors that acquire the data from the real world and into the computing engine. There's no single company that can handle all the requirements. You need to take the data from the image size, like video stream or the pictures. There's some audio data, there's some time series data, and there will be also some control data that is required in these processes. So the ecosystem will be quite important to put those technology together, which they also have different specialties in different areas. The most important thing is how we build all these parts in a single big system. So as you can see in the autonomous driving vehicle or in the robotic, it is a large system that composed by different subsystems. And normally there's a lot of sensor interactions and it's required to do all these tasks. Sometimes we call it sensor fusion, and these different type of sensor are provided by the different partners. So the ecosystem around all these applications are quite important to put this into work.
5G is right around the corner. What role does 5G play in AI at the edge?
There's one important part besides computing. If we talk about the edge AI, is connectivity. If you don't have a reliable and fast enough connectivity, all these interactions, all this collaboration between human machine or machine and machines are not feasible. So 5G is actually a big catalyst to make edge AI more applicable to the real world. As you can see, there's three important parts from the 5G, three important technology introduced by the 5G. Well, as the EMBB is enhancement for the 4G with a much larger bandwidth that you can transmit a much higher resolution video within the less time. And also the UILC, ultra reliable low latency communication. That is the foundation for a reliable communication with the wireless technology. The wireless technology is not popular in the embedded area because it's not reliable enough in the old days. But the 5G have helped solve this. And the third one is the MMTC. This is an enhancement for the NB-IoT, which means it can help to manage and control thousands or tens of thousands sensors at the same time. So that would be a foundation for the IoT to move forward. So put together, you now have a sufficient bandwidth. Now you have the capability to manage a large amount of sensors, and you have a reliable transmission way to transfer this data. So 5G is quite important to realize the AGI. Especially, there's one thing very special from 5G that is called private networking. So back in the old days in 3G and 4G, you have to rely on Vodafone, AT&T to provide you cellular network access before your iPhone, your devices to work. But in 5G, there's a way for each entity or enterprise or in that factory or hospital to build their own cellular network. So this small cell technology can help you to build your private, secure, reliable wireless communication. And that helps the AGI, especially when you trying to leverage some mobile technology in AMR or autonomous vehicle. That will be essential as an infrastructure to build up.
Now, Tiera Oliver explains Xilinx's recent innovations in AI architectures and software. In what may come as a surprise given all of the recent turbulence in electronics markets, Xilinx, the supplier of programmable logic device technology, reported growth across several of their core business units. According to Victor Peng, CEO of Xilinx, this includes high single-digit growth in their industrial, science, and medical markets thanks to wins in COVID-19 vaccine research equipment and platforms like the Mars Perseverance rover, as well as double-digit growth in automotive sales last year, where more than 80 million units shipped on the strength of demand for advanced driver assistance systems and autonomous driving features. How was Xilinx able to sustain its growth trajectory when so many others faltered?
When you need high throughput performance, right, that you have some degree of parallelism, you need high throughput performance. And you also need some good latency response, right? In some cases, it's indeed real time. In other words, you can't just batch it all up and just do it offline. Those things are really good for us.
Peng explains.
Also, when you have a need for not just one thing that you do over and over again, but you're going to optimize things over time, and there's a lot of change because there are new innovations you want to quickly deploy over time, or because you want to swap out different kernels, right? You want to accelerate different things. You know, those kinds of applications we're really, really good at.
But most of us already knew that. The company has been developing FPGAs that support these requirements for decades. For context, Intel stayed the course with its core technologies last year and saw losses in Q3 and Q4. The difference, at least in part, may have to do with the company's emphasis on AI.
Back in 2018, we talked about how, the world is becoming smart and connected, and smart in this case is actually, not just having some sort of microprocessor or microcontroller, but actually, embedding AI into a lot of these applications. Things are scaling out all over the place. Pace of innovation is increasing, and, end of Moore's law, data explosion, so on and so forth.
He explains.
We're unique in the sense that because of our flexibility, that we could accelerate a pretty wide range of AI, but also the non-AI portions. And most applications are not just completely AI. They're doing lots of other processing, and they have multiple neural networks embedded in them. Automotive is a classic example, but there are many more. So we coined the term whole application acceleration because it's really unique in that a lot of people are doing specialized chips that accelerate, a small class of neural networks, but they don't really accelerate other kinds of processing. And, I think it's really a unique competitive advantage of ours that we could accelerate a broad range of AI as well as other non-AI processing. So we could really deliver a whole application acceleration, right?
The company's new 7nm versatile tiled architecture, which integrates an AI engine, improves ML inferencing performance by 20 times in GoogleNet image classification, while consuming 40% less power than its 16nm Xilinx ultra-scale predecessor, an increase that stands up to the competition as well. The devices demonstrate a 20 times performance improvement executing Google speech commands over the NVIDIA V100, and almost 3 times uptick on ResNet 50 workloads compared to NVIDIA Tesla T4 per benchmarking data from partner Numenta. Versal is part of the company's Adaptive Compute Acceleration Platform, a line of multi-core heterogeneous compute engine that provides scalable performance and power consumption by coupling FPGA fabric, DSP blocks, and other programmable cores and high bandwidth memory via network on chip.
On the same piece of silicon with our architecture, you get factors of improvement. And you don't get this with other architectures, right? Like if you in software optimization with a fixed architecture, you get 20%, 30%, that's pretty good. Nobody gets like 3x with the same piece of silicon, right? But you actually can do this with our architecture.
There is enough performance headroom in the architecture that Peng and his team plan to keep the Versal product line at its current process node for the foreseeable future, in the next generation and potentially beyond.
You're going to get the traditional significant performance boost when we do these next generation of silicon architectures. But before those silicon architectures come out, you can get significant performance boosts by things like overlay domain-specific architectures. You could also do things like what Numenta is doing and others are doing, just really novel, innovative ways, right, to compress and accelerate neural networks, right? Everybody's doing quantization with different data types, and then I mentioned sparsity, and there's just a lot of richness in what you could do. So the key takeaway here is we absolutely have a roadmap of how we're going to evolve the AI engine architecture over silicon, next generation silicon. But in the meantime, we and our partners will rapidly innovate and drive performance even higher, through things like, sparsity.
And as Peng notes, it's not all about sheer compute performance.
I really hate how, especially in AI, everybody's infatuated with TOPS, right? Because what's limiting the performance of AI is more often the data and the data movement and the memory, right? And so the other thing that's unique about us is we let you optimize the data path, right? The data processing, mixed precision, all this other stuff. But we really let you customize the data movement and the memory and the memory path. And that really gives you true sustained performance, not peak TOPS numbers, right? And really, ultimately, if you do a good job of it, you're more power efficient, you're more energy efficient, right?
But despite these technical advantages, so often it's not as much about simply having a superior technology as superior usability. Just look at the Windows operating system and the iPhone. Recently, Xilinx has addressed this in non-traditional ways for a semiconductor company.
We've been moving up the abstraction stack, if you will. Our customers that really are expert in RTL, absolutely continue to add value to them, but we're also giving them some at least options to develop at a higher level of abstraction, but we could also help enable people who traditionally haven't used our platform. Right, so application developers, AI developers, data scientists, and so on. And I like to use the terms accessibility and not just talk about ease of use, because most people talk about that, and I'm not saying that we haven't and don't need to continue to work on ease of use. But what I mean by accessibility is not just the experience of the development environment, but the having access to a lot of different optimized libraries, using languages that people are familiar with that aren't hardware developers, interfacing to standard frameworks like PyTorch and TensorFlow, Caffe, and so forth, and then also driving an ecosystem. It's really that entire, menu of things that make it a much easier platform to develop. And I think we've really made a lot of strides on all those fronts. Certainly, with Vitis, as far as a single common development environment.
This even extends beyond the Vitis software development environment, as the organization has ventured into the business of hardware modules, first with smart NICs and data center acceleration cards, but more recently with embedded hardware platforms like Kira that have been designed for use cases like AI Edge and machine vision.
So you're going to see more of that, and I think this is a win-win because our customers can still differentiate with our cards, but now we're giving them closer to a complete solution, in a few cases a complete solution, and that helps their time to revenue, and it helps our time to revenue. And I would also say that I think it really helps people that maybe don't have the expertise to get down to the hardware level to optimize everything. They really, can get more of that complete solution, right? So in a sense, this helps expand our user base.
All of these factors have contributed to strong performance in AI sockets and obviously the market as well, based on the company's growth. So what is the ceiling? Now that much of the turbulence from the last couple of years appears to be behind us, it sounds like Peng thinks there might not be one.
The size of the opportunity at the edges is larger even than the data center, even though the data center opportunity is very large. And one of the things that I think is always been so exciting for me personally, being at Xilinx and now joining up with A&D, it's going to even accelerate that, is that we really have the opportunity to play in both those areas, right? End to end. And we do. A lot of people talk about end to end. We actually really are end to end in all those areas, and all those areas are growing. I know I'm not directly giving you like a number, like we're going to capture 30%. So, because I'm not sure that I'm really that smart, right? But I'm telling you the characteristics of the workload. And I think that's an expanding workload. It's not, look, CPUs are great at procedural stuff, right? And they have some degree of parallelism with, instructional parallelism with threads, with cores, but that peaks out at some point. Like the new workloads like video and everything, that's, as they say, embarrassingly parallel. But if you need live streaming, so you also want, it's not just offline processing, we're really good at that. You want to augment that reality with other things real time, like a sporting event with something that overlays, on top of the player, like all the stats and what they're doing. We're really good at that, right? High frequency trading, we're really good at that. You can't be in a more exciting time in the industry right now, exactly because the old ways of doing things is just not going to cut it. People are looking for 20, 30% improvement. They're looking for 10x, 100x. I mean, I even talked to one customer, like ultimately wants like 1,000x improvement. I mean, the need for computes is just about infinite, and when you fix the compute, then you have a storage issue and you have a network bandwidth issue. So really, I think it's really exciting, and we play in all those areas.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.